Standard 7 Subject Science Lesson number 18 Sound Part 3. In our previous video we had studied about oscillator, oscillation, oscillatory motion, amplitude of vibration. Now we are going to study about time period of oscillation and frequency. Let's discuss about time period of oscillation and frequency. We have seen the diagram of pendulum in the previous activity. The time required by an oscillator. One oscillation is called the time period of the oscillator. In the previous activity, the oscillator travels the distance from the extreme position B to central position A and from there to the position C, then back again to A and from A to B. The time required by the oscillator to traverse this distance B to A to C, C to A and A to B. So, is the time period of oscillation T of the oscillator. The number of oscillation completed by an oscillator in 1 second is called the frequency of oscillation. So, the total motion BACAB in the previous activity is 1 oscillation. Frequency is equal to 1 upon time period of oscillation, that is 1 upon T. So, the frequency is the number of oscillation occurring in 1 second. The unit of frequency is Hertz. 1 Hertz means there is 1 oscillation in 1 second. 100 Hertz means 100 oscillation in 1 second. Frequency is F equal to 1 upon T. Period T is number of seconds per oscillation. Frequency F is number of oscillation per second. The number of oscillation per second is called the frequency of the oscillation. Frequency is expressed in the term of Hertz. Let's try another activity, production of sound. Take a plastic ruler and hold one of its ends pressed down on the table as shown in the picture, so that a large portion of the ruler is off the table. Now, ask your friend to press the free end of the ruler down and release it. Observe what happens. Now, press the ruler with your finger at such a point that it stops making any sound. Now, pull in 10 cm more of the ruler onto the table and repeat the action. Listen to the difference in the first and the second sound. Take note of the difference in the frequency and the pitch of the sounds. Also, take note of what happened by further decreasing the length of the free part of the ruler little by little. Will a sound be generated no matter how the ruler is kept on the table? If you perform the same activity by placing the ruler at a different position and distances onto the table, you will see that sound is not produced by placing the ruler in any position. If the ruler is placed straight or erect on the table, then the sound is not produced. If most of the part of the ruler is on the table and only a little part is out of the table, then the vibration are not produced in the ruler and thus the sound is not produced. Is there any correlation between the length of the free part of the ruler and the sound is generated? The length of the free part of the ruler and the sound generated are related to each other. The length of the free part of the ruler and the sound generated are related to each other. The sound coming from the ruler changes according to the length of the free part of the ruler. If the ruler is plucked while it is held with 25 cm of it off the table, does it make sound? It does not produce any sound because the frequency of vibration produced that time will be very less. We can only hear sounds of particular frequency. So, a longer ruler vibrates more slowly, so has a lower frequency. A shorter ruler vibrates more quickly, so has a higher frequency. Lower frequency waves have a lower pitch. When the ruler is shorter, it vibrates more quickly. So it makes higher frequency pressure waves which have a higher pitch. Thank you.